ready? You ready? You ready? You ready? You ready?
Sure.
Now that Claudia's back, we can go ahead and we can start this thing. What? We're trying to find P95. Recall, that was the 95th percentile. Sure. If we're looking at the 95th percentile and we're thinking about a normal distribution, it is going to be on the right-hand side right over there. So that 95% of the area is to the left of that value. So in order to find the 95th percentile, we need to find the corresponding z-value. Whoa, stop. Back that math up. That was premature. We need to go, to the next page. Yeah? And then we'll back this up. Back. There we go. So if we go in the back of the book, we're trying to find z-value when we know z-area. Z-values are on z outside. Z-area is on z inside. So we need to go to our chart and we need to find the value closest to 95%. Where's that going to be? We're looking for 0.95.
So it'll be 165.
Or 164.
Yeah.
And when it lies exactly in between two numbers, as you guys are suggesting, 0.9495 and 0.9505, if it's exactly in between those, we can use this idea of interpolation, and we can average those two to get a more accurate z-value. And when we average 1.645, because we're averaging the z-values, we get our z-value to be 1.645. And that's one of your magic numbers. So now where do we want to go? We want to go back to this other slide. You've seen too much. Boom. So what is that z-value? That z-value is 1.645. Now let's take it beyond just finding the z. Let's use the z in a two-part problem. One, you find z, then find the corresponding x. So we need a scenario. And here it goes. Let's use milk. Okay, we previously discussed that milk probably goes bad in 14 days, and then it has a usual standard deviation of like 2. And if we had this z-score over here, this transform, it's more than meets the eye. Whoa, what just happened here? I don't know. I'm just going to go with it. So we go with it. And you're capturing a whole bunch of stuff. I don't know. Anyway, so what do we have? We have a standard deviation, and we have an average, and we have a z-score. If we're trying to find the value of super milk, the milk in the 95th percentile, super milk, right? Like you shouldn't drink milk after this many days. We're going to go and we're going to plug that in. We're going to find super milk, the 95th percentile of milk going bad. This is the one, you wouldn't want to drink it after this because there's only like a 5% chance that it's still good. So we go and plug that stuff into our z-score to find our x. Then what's next? We need to multiply that too. Wilmer, wake up. I need your skills.
Yeah, sorry.
Yeah.
Times 2, 3.29.
3.29? 3.29. Now, did you round too early? No, because 2 times 5 carry a 1. Okay, that's why that's 0. And then that's going to be equal to x minus 14? Right. So now add 14 to that.
17.29.
17.29. So what does that say? If my population parameters are true and milk lasts 2 weeks with a standard deviation of 2 days, then you don't want to drink milk that's more than 17.29 days old. So that would probably get you through breakfast.